Morning class. I was looking over your exams and we need to take a little look at some review. So we'll do a bit of review here. So for the first few questions on your exam, you are required to rearrange a system of equations into mx plus b form. Okay. I felt like most people understood how to do independent, dependent, or inconsistent lines. Though some of us struggled with rearranging these equations into an mx plus b form. So that is a review of algebra. So let's do that. So follow along with your own notes, and then I'm going to ask that you fix these questions if you do need to fix them, and we'll do a few practice problems that involve rearranging equations. Okay, so I'm going to work with this first question from the exam. I'll rewrite it. The system is this: x minus 5 is equal to negative y, and 2y minus 10 is equal to negative 2x. So the first piece of review that we might want to consider is always think of this minus as belonging with this term. So this is a negative 5. Here we have an imaginary plus. And for the sake of argument, you might want to consider or have the knowledge that this is the exact same thing as 1x, right? 1x, or just x by itself, and this would be a plus 1x. If you really wanted to, you could write it like that. You're not going to see a text write it that way. Its simpler form would just be x. So I'm going to rewrite this equation. I need to work with each one. What I notice is that some of you just want to rearrange things without following algebraic rules. Okay, there are some rules here. Whatever we do to one side of the equation, we must do to the other side of the equation. So with this one, I'll rewrite it off to the side. X minus 5 is equal to negative y. I want to move this so that I get a y is equal to mx plus b form. So it is very close to being in that form. Actually, it essentially is. I just need to rearrange it a little bit. And I would like to get rid of that negative on the y. So if it's helpful, let's just rewrite it as you're used to here. Now, it doesn't matter if you move it this way or that way as far as rearranging these things. I can rewrite this as negative y is equal to, there's a positive x, right? And minus 5. So now I kind of have it in a mx plus b form, right? We're going to evaluate these. It's close. I don't like dealing with this negative here, so why don't we multiply by a negative? So if I multiply by a negative 1, and multiply by a negative 1, and multiply by a negative 1, everything needs to be treated across the board when we multiply. So that a negative times a negative, and think of this as negative 1y times negative 1, would yield y. X times a negative 1 would equal negative x, and negative 5 times negative 1 would yield a plus 5. Okay, now we have mx plus b form. Let's try this second one. So I have 2y minus 10 is equal to negative 2x. I want to have it as y is equal to something. So here we'll deal with dividing. So I'm going to divide everything on this side by 2. And I need to divide everything on the other side of the equation by 2. That'll at least get us to a y, right? Won't solve all of our problems, but it'll get us there. So this now becomes y. I'm going to skip down just a little bit. Y 2 over 2 is equal to 1 minus 5, 10 divided by 2, is equal to negative x. 2 over 2 is 1, and I have to keep this negative. Okay, a lot of us don't want to keep that negative. Some of you, it just disappeared. Things can't just disappear. That you have to perform an operation, divide, multiply, add, do something, but you can't just get rid of it. Okay, so we just need to move some things here to the other side of the equation. How about we add 5 to both sides of the equation? Okay, so if I add 5 to this side of the equation, it will just become y, right? Negative 5 plus 5 is 0, y plus 0 if you wanted. I won't write the 0. Y is equal to negative x plus 5. So the second equation turns out to be exactly like the first equation. They are the same equation. Now, if you look back at the original equation, you might be able to pick up on that. Here's a y, here's 2y, here's a negative 5, here's a negative 10. Here's 2x, there's x. However, this negative here for the y makes it a little more tricky to be able to determine without maybe walking through the algebra if these are exactly the same equations. And one way to look at this is to quickly say to yourself, if I want to make this side, get rid of this negative, I'll just change all the signs over here, right? So this becomes negative, this becomes positive. And then you could evaluate maybe a little easier, but you know, there's enough confusion in that problem, you probably need to solve the algebra out. Okay, so let's try a second problem here. This will be the second one from the exam. Again, we're evaluating, and we need to use the mx, y is equal to mx plus b form. So I'll rewrite this equation. X plus y is equal to 3, and y is equal to negative 2x minus 1. So let's go ahead and try to move these into y is equal to mx plus b. So I see that I can subtract 2x here. So I want to subtract 2x from this side of the equation, and I need to subtract 2x from this side of the equation. So that will yield y. It's a positive y, doesn't change. I take away the 2x, it's going to come over here, and I have 3 minus 2x. It's not perfectly in the y is equal to mx form, so let me just go ahead and change it, or rearrange it. Sorry, I'm not changing anything. This is a negative 2, right? So I'm going to write y is equal to negative 2x plus 3. Okay, let's work with this one. And this one is in the right form. It doesn't need to be changed at all. Y is equal to negative 2x minus 1. Okay, so these two equations have the same slope, but they have different y-intercepts. So if you think about that as just an example, and I'm feeling most of you are, if not all of you are good with this. If you think about this, if we were to put in some numbers, an equivalent slope, right? This is just an example. This is not the actual graphs of these, but an equivalent slope, right? So the slope, right, there's one line, and if you had another line that was exactly the same slope, right, no matter where it's at, right, once again, this is not actually the graph of these lines, but if it has the I missed something here. This needs a negative. They do have the same slope. It was a negative 2x. So if they have exactly the same slope, negative 2x, but one is at positive 3, here's the intercept, right? I drew it at positive 2, but you know, you move this line up 1, and the slope isn't quite right either. But and this one is at negative 1. These lines, when they have the same slope, they're going to be those parallel lines, and that's going to result in an inconsistent system of equations. There's no answer, no intersections. Okay, so this had, as far as grading goes, this to get this one in the proper form. This first one, to get this in the proper form, this was like number 1, this was number 2, and then because they're exactly the same equations, you had to say that they were dependent. That's number 3, and then this would have been number 4 to get this in the right place. This is 5, and then evaluating this, you would say that this is inconsistent for 6. Okay. Now, you know, I feel like when we do this, when I do it, you tend to you follow along. You're familiar with some of those rules and practices. But let's just, if I rewind for a second and just go back to the whole idea of what you do to one side of the equation, you must do to the other side of the equation. Just the logic behind this, okay? Okay, what I want to do here is I want to just take a step back and look at some basic algebra from what we've been doing here, and just go back a step and just look at logically why this works. why is it that we are working with adding, subtracting from one side of the equation, we must do it to the other side of the equation, and multiplication and division. So we basically have 4 functions. So I just want to make an expression here. So we're just going to work on this logic. Take a step back for a second, and we'll just think about this for a second, what we've been doing here. So I'm going to write an expression here. 2 plus 2 is equal to 6 minus 2. Okay, this is a true statement. 2 and 2 is 4. 6 minus 2 is 4. 4 is equal to 4. Okay, so now what I intend to do is do our 4 operations to this equation to demonstrate the logic of what we're doing. The first thing we're going to do is we're going to add. Now, it should be said, it doesn't matter if these were variables. For example, if 6 was represented by x, you would still need to do everything the same way. So numbers and variables, same idea. Okay, so we say that you need to add to both sides of the equations. So for example, right here, like if we wanted to get rid of this 2, we could add 2 to this side of the equation. We must add 2 to this side of the equation. I'm just going to go ahead and add 2. Now, I could just put 2. I'm adding 2 here to the front side. 2 plus 2 plus 2. So I added 2. A positive 2 is equal to 6 minus 2 plus 2. So I added this 2, and I added this 2, or you could even think of it as this 2, to this equation, right? So I added 2 to both sides of the equation, and essentially negative 2, recall that this minus 2 associated, this plus 2 would go to 0. But we don't need to do that now. We can just look at it. So 2 plus 2 plus 2 is 6. 6 minus 2 is 4, plus 2 is 6. Yep. So 6 is equal to 6. So what did we do? We added. We must do it to both sides of the equation. It makes the equation maintain its integrity. Okay? We can't just add 2 to this side and it would be a fallacy then. It's an algebraic process here. All right, so we did addition. I'll rewrite our equation here now. So we have 2 plus 2 plus 2 is equal to 6 minus 2 plus 2. So we've thrown in an addition. Now I'm going to subtract. So whatever I do to one side of the equation, I must do to the other side of the equation. Right? So I think I'll subtract 3. So I just write, I'm going to subtract 3 from both sides of the equation. Okay, so I'll now rewrite it as 2 plus 2 plus 2 minus 3 is equal to 6 minus 2 plus 2 minus 3. I could solve this equation. I mean, I could make it, reduce it, do the math here, but I want to demonstrate that by just doing these things to both sides of the equation, it doesn't matter where it would be in the equation. Here they both appear at the end. On this one, I actually put the 2 in the front and this other one at the back. It doesn't matter here. If you add 2 to the end or the beginning of this expression, it's going to be the same. Here I put them, just took away 3 at the end. So 2 plus 2 is 6 minus 3, 3. 6 minus 2, 4, plus 2, 6 minus 3, 3. 3 is equal to 3. So it maintains its integrity again. All right, now we'll do some multiplication. So if I multiply, this is blue, so I'll go 2 plus 2 plus 2 minus 3 is equal to 6 minus 2 plus 2 minus 3. Okay, but I want to multiply this equation. I think I'll multiply it by 2. So it's two ways to think about this. Think about this as like you're going to be multiplying this entire piece times 2. Okay, that would be like distributive now. 2 times 2, 2 times 2, 2 times 2, 2 times negative 3, minus 6. Or you can see that sometimes I write it like this. I put the negative, or the 2 here, times each one of these. Right? Same idea. I just go about showing that I'm going to multiply each one by 2. Right? This is the same thing here. It's just going right through. So 2 times 2 is 4, plus 2 times 2 is 4, plus 2 times 2 is 4. 2 times a negative 3 is negative 6 is equal to 12. 6 times 2, negative 2 times 2, negative 4, plus 4 minus 6. Okay, so I've doubled everything. Just doubled it. Now, you could, in doing your rules of operation, you could just go 2 plus 2, 4, plus 2, 6, minus 3, 3, and do that inside, and then multiply by 2 and get 6, because that's going to be the same thing in the end, right? There's 4, 8, 12, minus 6, 6. You know, the rules of operation work as well, right? But just to demonstrate that we multiply this side and we multiply this side, I showed you two different ways. You'll often see me do it this way because we're going to be working with a variable. So it becomes a little easier. But you're very familiar with this distribution. You could write it like that. Okay, so it's maintained its integrity here. Now we'll go about dividing. So let's divide. All right, I think I'm going to rewrite it here. So here it is, 4 plus 4 plus 4 minus 6 is equal to 12 plus 4 minus 6. Okay, I think I'll divide it by 2. So now when I write like that, you have to understand that everything is divided by 2, not just the first 4. Okay? This needs to be divided by 2. This needs to be divided by 2. This needs to be divided by 2. Or if you were to think about this in parentheses, you could add all these up and divide by 2. Okay, but you can't just divide the front 4 by 2 and think you're done. Everything is divided by 2. That's why sometimes you'll see me write it like this. I'm going to divide this side by 2. Okay? So everything on this side needs to be divided by 2. Okay? If we go about doing this, 4 and 4, 8, 12, minus 6, 6 divided by 2 would be equal to 3. 12 divided by 2 is 6. Minus 4 divided by 2 is 2, plus 4 divided by 2 is 2, minus 6 divided by 2 is 3. 6 minus 2 is 4, plus 2 is 6, minus 3 is 3. Three is equal to 3. All right? So, just logically thinking these things out. Here are your 4 operations, right? You're going to add. You need to add to both sides of the equations. And subtracting, it's really the same thing as adding, because you can add a negative. Think about it that way. And then multiplication. Showed you that you can use this distributive property. You'll see me write it like this because there's variables involved. Same thing. Different ways to look at it. And then when we divide, just make sure you don't just divide it once. This, if you do a division sign like this, put a 2 here, you have to understand that it's the entirety of that numerator. Okay, and we divided. So you can do these different tricks all you want. You can even zero out this side, right? Like if we were to subtract 3 from this side of the equation, we would need to subtract 3 from this side of the equation, and we would get 0 is equal to 0. Still true. So even if you working with variables and things and you zero one side of the equation, it's not a big deal as long as you're following the rules. Okay, so hopefully a simple logical explanation of what we are doing in these problems. For example, right here, we added 5 to this side of the equation, so we must add 5 to this side of the equation. Okay, in order to maintain the integrity of the equation. Just like we added 5 or added 2 here. No big deal when we did our addition. All right.